Okay, so the last thing we calculated in the graph in the last video was r squared. So there's a video in here explaining r squared. I would highly encourage you to shift click or control click and watch that. Um, r squared is noted as r with capital R squared, right? It's not lowercase. So what it is, it's explaining the variability of x to y because it's not a perfect model, right? So basically, you have the overall variability between the variables, right? So essentially, x only explains part of the variability in the y, the output, right? And the rest of it is unexplained, okay? So the r squared value is between 0 and 1 and is represented by this formula here, okay? Although we don't need to do this, we can simply go to our spreadsheet to this and put in r squared, right, equals, make this a little bit bigger, right, copy this, paste it, and simply paste it, okay? All right, so let's get this out of the way for now. So all I have to do is r to the second power, and I get that. So I get a positive value. So I get equals r to the second power, okay? And I get r to the second power. Okay, so r versus r squared, right? R goes between, let me get rid of this. Goes between -1 and 1 inclusively, right? R squared goes between 0 and 1 inclusively, okay? This tells you quality and direction of the linear data. This tells you the relationship and variability between the data, essentially, okay? So it's a percent is essentially what it works out to be. Okay, so if I look at 3 examples here, this one here is saying if r squared is 1, approximately 100% of the variation of the y is accounted for by the x. Okay, and this one here is saying essentially 83% of the values variation of y is accounted for by the x. So the rest of it must be something else, so the 17%. And then this one here, you can't technically get 0, but you get approximately 0. None of the variation of the y value is accounted for by x. So how much does x actually affect the y, right? Variability wise. So if I look at this here, I have the lectures per day, and the output is a number of hours spent at the university. Well, just because you're spending time at the university, does that mean it's just because of lecture? Maybe you're going there for food or study group or something else. Who knows, right? So only 89.5% of it is actually the percent that's accounted for by the X number of lectures per day, right? So let's say you have a burger, right? It has protein and fat in it, right? So the fat does not always come from the protein. It can come from other places. So what this is saying is if it's 0.58, that only 58% of the variation in the fat approximation is a variation is accounted for by the protein. The fat will be coming from other places essentially. And if you have a 0.773, 77.3% of the variation in the hurricane's maximum wind speed, because that's being predicted as the wind speed, correct, is accounted for by the central pressure, right? So the rest of it must be from somewhere else, essentially, which could be temperature of the water, terrain, other things like that. So it's not perfect, essentially. So if I look at the models that we're doing, right, we can only say 96% of the car sales are due to revenue, maybe some add-ons to the rest of it, basically. Here, only 89% of it. Some other things might be, I don't know, the weather, how you're feeling, some other things besides your absences, maybe you didn't do your work. And then here, very little of the teacher quantity actually has to do with the ratio. The rest of it is 80% other factors, essentially. Okay. All right.